This conference will now be recorded.
Okay. Okay. Before starting the demo session, right? Let me introduce myself. My name is Vishnu. I'll be handling the front end training, advanced aspect of the training in front end. That is UVM, AXI protocols, those kind of things in VLSI Guru Institute. So I'm having around 7+ experience in front end verification itself. So where I also explored the aspects of RTL design as well. Okay. So today's session, I'll be handling front end demo for freshers. Okay, so you guys have enrolled VLSI Guru for front end design verification training for freshers, right? Or front end functional verification training for freshers, right? Both of these trainings are same itself. Okay. Okay. So yeah, I'm sorry for that. So you guys have enrolled for front end design verification, right? And front end function verification training. So both of the aspect is one and the same itself. Okay. So where we'll be learning around the VLSI front end flow. Okay, starting from means VLSI front end flow starts with the uh, architect level, where the design inputs means what are the components to be gone, what are the features to be present into a design. Let's say you are dealing with a Intel processor. What are the features that are that are present for a processor? Those features in feature decision happens in the architect's level. So after architect level, the flow is with the RTL design engineers. So where the RTL designs come up with the each features of SoC, such as Intel processor or Snapdragon, Qualcomm Snapdragon processors. Okay. So the next is coming to RTL integration. So where the multiple subcomponents which are developed by the RTL engineers gets integrated to form a bigger subsystem or a bigger chip. Okay, that is the role of an RTL integration engineer. So the next role comes with respect to the verification, that is RTL verification engineers or design verification engineers or functional verification engineers. So where we verify the given subsystem or a given block or a given design, we verify it thoroughly. Okay, what do we verify? We verify the features of the design thoroughly. Okay, suppose if your SoC has a your laptop, let's say, let's consider a laptop as an example. Your laptop has a pen drive port, right? Every laptop has one USB port actually, where you connect a pen drive, for example, right? So as a design verification engineer, if you are working on a USB functional verification in your design, so you will be responsible for data transfer present from the USB port into your internal SSD memory which is present. Getting my point? So you have to verify the aspect of the memory the data transfer present between USB port to the internal laptop memory, that is SSD memory what we have, right? So again, it's not as simple as what I just told. It's not like just you access the memory USB port and you store the data into your laptop. There are multiple subcomponents which comes in between, right? So in our front end, I mean in front end demo session or in the front end training, right? So uh, we focus on teaching you the verification aspects from the bottom level to the complete verification flow. That is, we start from digital design actually. Okay, the front end verification training starts with digital design. Why digital design? Can anyone tell me why digital design is important in learning VLSI? Can anyone tell me? Yeah, so basically when you do any operation in a hardware, like in your mobile chip, any operation, if it happens with respect to what? Gates and transistors only. Yes or no? Even if you want to come up with a small functionality such as addition, adder, in your, you do 1 plus 1, right? That addition logic, what you do in your hardware, even for doing the addition logic, you want gates itself, right? So all this knowledge we'll be learning with respect to what? Digital design topic. See, basically any hardware fundamentals is what? Digital design. Okay, you verify, you suppose, let's say you want to build a, let's say, you want to build a multiplier circuit you want to build, right? So how will you going to build a multiplier circuit? You will be needing the basics of digital circuitry knowledge. Yes or no? So digital design acts like a basic fundamental for any of the VLSI hardware implementation. Okay, so we start our functional verification for freshers with a digital design topic. Okay, where digital design is not only focused on the basics of digital, but also it is focused on interview aspects of interview aspects actually. Suppose let's say tomorrow you will apply for interviews, right? In interview they won't ask you simple questions such as explain half adder, explain multiplier, explain 2 cross 1 multiplexer, right? Those kind of simple questions they won't ask actually. So they'll ask tricky questions. Okay, so those tricky questions, we um, help you to solve it. Okay, or we help you to find a path for the solution. We teach you the logics, how to find the solution for it. Is it clear? So digital design has both combinational, means in digital design, right? Circuits. There are two things of digital design circuits. One is combinational circuits. Second is sequential circuits. In both of these aspects, we will learn the basics plus the interview point of questions will be targeted on. Is it clear? So this digital design will be common for any of the VLSI courses. What you will opt for in VLSI Guru. Okay, so that is front end if you opt for, or else if you opt for back end such as physical design, custom layout, analog layout, right? Any of these things, digital design will become the basics. Okay. So next, once digital design is completed, right, we'll be going through Verilog. Okay. So again, Verilog, see, as a verification engineers, okay, we will be requiring the knowledge of RTL actually, design, okay. So as a functional verification engineers, we'll be requiring to know the knowledge of how a design is coded actually. So the design code is being done with respect to Verilog. So we call it as a RTL, registered transaction level coding. Okay, RTL code we call it as. Okay, so for ASIC flow, right? For ASIC flow, okay, what is ASIC flow? Application specific integrated circuits. Okay, ASIC flow means what? Application specific integrated circuits. For ASIC flow, the RTL code, example for an RTL code, I'll tell you half adder RTL code. Okay, the half adder circuit design code. Okay, if you want, we can do it by using Verilog. Okay, you all have come across uh, your Snapdragon, Qualcomm Snapdragon processor, which goes into your Android mobile phones, right? Yes or no? Have you come across it? Qualcomm Snapdragon processor, which goes into your mobile phone, right? That chip, the Snapdragon chip is there, right? That chip is called as a ASIC flow chip, ASIC chip actually. Okay. Why ASIC? Because why ASIC? Because the chip what is getting manufactured, such as Qualcomm processor, it is manufactured for specific application only. For example, that is mobile phone application. Okay, so that is called as an ASIC chip. Okay, so for that ASIC chip designing, we use Verilog as a coding language. Now, when you go for verification aspect, you will be verifying the Qualcomm Snapdragon processor. Okay, you'll be verifying the Qualcomm Snapdragon processor. So during your verification stage, right, you might come across some bugs actually. Okay, what is bugs? Unexpected behavior in a code is what we call it as a bug actually, right? What is maybe unexpected behavior? An example is, 1 plus 1 is equal to 2. Yes or no? A simple example I'm going to tell you actually. Okay, you know that 1 plus 1 equals to 2. Do you agree? Yes or no? Right. Suppose if the design gives you an output as 3, is it correct? If your design provides an output as 1 plus 1 equals to 3, is it correct? Wrong, right? Do you agree it's wrong? Online guys, do you agree?
Yes. Yes.
Yes.
Right? Now, how will you debug that? Now, question comes, how will you debug that? Okay. And assuming that, let's say, design itself is going wrong, assuming the design is giving me a wrong input, how will you debug that issue? That is where you need to be capable enough to open the design RTL code. Open the design RTL code. Open means what? Open the file of a design RTL code. Open the file actually. Okay. Open the file of a design RTL code and check the logic. You should be able to trace the logic. Okay. Now to trace the logic, you know that RTL code is developed using Verilog. If you have the knowledge of Verilog only, you will be able to understand the logic of the design, and you'll be able to trace which logic is having the issue. Do you agree with me? Yes or no? Everyone?
Yes.
Right?
Yes, sir.
See, simple. What I'm saying is simple. What I'm saying is, you know that there is a design issue present. Okay. Question comes, how will you confirm that the design itself is causing an issue? Which logic of the design is causing an issue? How will you confirm it? You have to open the file. Yes or no? You have to open the code and you have to debug the code. Open the code, understand the code, debug the code. When you open the code, if you want to understand the code, you should be able to. If you want to understand the code, you should be having knowledge of the language in which the code is being written. Do you agree? Yes or no? Now, ASIC flow chips, the RTL code is written in Verilog. If you have the knowledge of Verilog, then only then you will be able to debug the design issues present in the design code. Yes or no? That is where we'll be learning regarding the Verilog aspects. Now, Verilog, we have divided Verilog into two aspects. One is the Verilog language aspect. Verilog language aspect. In Verilog language, what do we learn? We learn regarding the data types. Means Verilog language constructs. Verilog language constructs. Constructs are data types in Verilog. How to write a module. How to write a module. How to write a module. Okay. Task and functions. Okay. There are blocking statements. There are blocking statements and non-blocking statements present. Statements present in Verilog. Okay. So means how to write task. Okay, task and function already done. Blocking statements and non-blocking statements. How to write combinational design. and sequential design circuits, right? How to write test bench, how to write test bench, Verilog system task, etc. I will say. See, basically, when you start with each module, you'll be going to the complete topics. What will be covering in the Verilog language. Okay. So basically, the complete Verilog language will be learning to understand how to write a RTL code. To understand how to write a design code, we'll be going through Verilog language. Okay. Is it clear? So see, if you are very strong in digital design, if you are very strong in Verilog language, one can also land a job in RTL design engineer also. One can also land a job as a RTL design engineer as well. Actually, if you know what digital design and Verilog in depth, I'm saying in depth. Is it clear? In digital design, we'll also learn about CMOS also. In digital design, we'll also learn about CMOS as well, actually. Basics, because it is needed. CMOS understanding is required for a VLSI engineer. Okay. Is this clear? So one aspect of Verilog training is Verilog language. The second aspect is the Verilog projects. Second aspect is the Verilog projects, actually. See, why we will learn projects? Because whatever the language we have learned, we need to know how to practically use it in the real-time projects. Okay, so there are few real-time projects what we have included as part of the training. Okay, so these projects you can look up into these projects in you can look into these projects in there is VLSI Guru design and verification course present. So in this course, you can go through the Verilog. You can go through this Verilog language. Okay, in this Verilog language, all the list of topics have been given here. Language point of view, what are the topics we will learn? Okay, that is literals, data types, registers, nets, vectors, arrays, operators. Right, all of these topics will be covering as part of language point of view. Then we'll be learning projects, as I told you, Verilog projects to practically know how to implement the Verilog language and write a RTL code. We'll be going through multiple projects in VLSI Guru, such as starting with the basic digital circuits such as D flip-flops, where you understand how to declare a clock, how to declare resets, synchronous resets, asynchronous resets. You'll be understanding different frequencies of clocks, how to generate. See, in hardware, clocks are generated with respect to crystal oscillator. That is different. But when you come to verification aspect, right? So the clocks will still be generated internally. Okay. So how to generate this clock is what we'll be understanding in the first project of the Verilog, that is D flip-flop. Okay, where we'll learn different clocks how to generate. Okay. Then some counters we'll be going through. Then we'll be understanding a practical project such as memory. A simple memory. See, every design has a memory present in it. Do you agree? Whatever the memory you speak about in your laptop, SSD, it's also a memory only. Yes or no? You have RAM in your laptop. That is also a type of memory. Yes or no? Right? So those type of memory, basic RTL level coding will be understanding in terms of Verilog here. How to write the RTL code for a memory, how to declare memory of 8 kilobyte, 128 kilobyte, those kind of concepts we'll be learning in terms of Verilog projects. Okay. Then we'll be going through see, memory, right? It has two types of accesses basically. One is called as front door access, back door access. Okay. Front door access means you tap into the interface of the memory signals and you load the data into the memory. Okay, that is what is called as front door actually, which basically consumes time. Okay, simulation time. Basically consumes simulation time. Then we are having one more concept called as backdoor access. Okay, see, backdoor access we perform perform because to reduce the to reduce the simulation time, we use backdoor access, where in Frendo, right, to access a 8 kilobyte memory, to store the data into 8 kilobyte memory. Okay, you might take, let's say, 15 minutes. 15 minutes it might take to access 8 kilobyte of memory, assume. Okay, in terms of backdoor, right, it will happen in zero time actually. Okay, practically, if you ask me, sir, practically what is being used, front door is used or backdoor is used in terms of laptops? Front door is what is used actually. So when you connect your pen drive, from pen drive to your laptop internal SSD, the data is getting stored with respect to front door access. That is the reason, suppose let's say you want to transfer a 1 GB of file from your pen drive to your laptop, it takes some 5 minutes actually. Do you agree? Minimum 5 minutes it takes to store the pen drive data into the laptop SSD, laptop storage, right? Laptop memory, SSD memory. It takes minimum 5 minutes actually. Why it is taking time? Because we are doing with respect to front door access. The backdoor access is only a verification concept. Okay, it's not a real-time concept. It is just a verification concept to reduce the simulation time. Okay, where backdoor access will happen in zero simulation time. Now the difference between front door and backdoor and practical application of this we'll be learning with respect to the memory project. Okay, so in real time projects, right, if you are working on any memory kind of designs in your real time project, if you're working on any memory kind of designs, okay, there you will do both front door access as well as backdoor access. Okay, so next we'll be coming across something called as a FIFO. Okay, FIFO, first in first out. It's also a type of memory which acts like a buffer between a master and a slave. Okay, so meaning is FIFO acts like a buffer. I told you. Basically, we are having two components. Okay, let's say component one, component two. Component one is is communicating some data to component two. Okay, between that we'll be having one FIFO. Okay, that FIFO, between that we'll be having one memory. That memory will act like a FIFO, first in first out actually. Okay, whatever the first data you put in, the same data should go out. That is what is called as first in first out. So those means this is used in real time SOCs where multiple components are present, and between two components, when multiple components are present, such as like this is component 1 and this is component 2. Okay, suppose let's say component 1 is operating in a higher frequency rate, that is, let's say 100 megahertz it is operating on, and component 2 is operating with only 50 megahertz, right? Do you agree that component 1 is faster in operation and component 2 is slower in operation? Do you agree? Frequency, you compare the frequency, 100 megahertz is more faster, right, compared to 50 megahertz. So component 1 is faster, component 2 is slower actually. So when this component 1 and component 2 are communicating any data between each other, in this aspect we'll be using something called as a FIFO here. Here is where we use FIFO. Why use FIFO? What is the advantage of using FIFO? Why are we, how to implement a FIFO? All these things we'll be understanding with respect to the projects in Verilog, such as synchronous FIFO and asynchronous FIFO. Okay, then we'll be understanding regarding state machines, Mealy and More state machines. Every sequential circuit is nothing but a state machine. Either it will be an implicit state machine or explicit state machine implemented using Mealy and More concepts. So those things we'll understand here. How to implement a state machine we'll understand in this project. So to do that, to understand the explicit implementation of a state machine, we'll be understanding over pattern detectors. Okay, where we'll understand regarding overlap and non-overlap concepts of the pattern detectors. Okay, so then we'll be going through traffic light controllers. Then we'll go through one project, one very important protocol in VLSI, okay, called as APB protocol. Okay, see, APB protocol is there, right? APB protocol, it is called as on-chip protocol. What do you mean by an on-chip protocol is? What do you mean by an on-chip protocol is? Suppose you have a suppose you have a SOC present. Okay, SOC means what? System on chip. Your Qualcomm Snapdragon is a system on chip processor. Okay, 1 minute. Yeah, SOC is there. Okay, now this SOC, right, it will be having some processor subsystem will be there. Okay, CPU subsystem. In general, it's called as CPU subsystems, GPU subsystems will be there. So here I'm telling you the example of a CPU subsystem. CPU SS means CPU subsystem. Okay. Now this CPU subsystem, right? Now the CPU subsystem, it will hold multiple. Suppose let's say a Snapdragon processor, it will hold multiple ARM Cortex processor cores. It will be there. ARM Cortex processor cores will be there, such as let's say A15 or A7. Say 4 an example I'm saying 4A7 and 2A15. A15 processors. A means what? ARM application series. See, ARM, everyone knows ARM processors. I hope so, right? ARM processors, right? So ARM processors are basically having three different profiles. Okay, A series, M series, R series. Okay, in that, suppose I'm taking an example of an A series application specific processors such as A7 and A15 processors we are having. Okay, so the basics of SOC architecture also are included in your front end uh, training. Okay, so here I'm just giving you one small example. That's it. Okay, so this processor has one interconnect. This we call it as an interconnect. Okay, and here we are having one here we'll be having one SPI. Anyone has heard about SPI or I2C? Have you guys heard about SPI or I2C protocols? For engineers, means for fourth year of engineers, in fourth year of engineers, you would have done some projects using Arduino boards. Do you agree? So there is something called as I2C interface present in an Arduino board, right? Where to that I2C interface, you'll be connecting some sensors actually, temperature sensor, for example, right? So similar to that, I'll keep here an example of a, Android phones, they're having a fingerprint sensor, right? So I'll keep here. Where is sensor? Is it present inside the chip, the fingerprint sensor, or on your mobile phone? My question to you is a fingerprint sensor present inside the processor, or is it present in your mobile phone?
It is present outside the processor, means it is on touch screen, means on screen the sensors will be there.
Yeah, correct. On the screen, correct. On the mobile phone, the display screen, beneath the display screen, there will be one small sensor present actually, right? That is what is called as fingerprint sensor, right? Where you keep your finger on it, and within a second your mobile will get unlocked, and you can use your mobile for regular operation, right? So that fingerprint sensor is what I'll be writing here. Fingerprint sensor is what I'm writing here. Fingerprint, I'll say fingerprint sensor, FPS, fingerprint sensor. Is it clear? Now, whenever you apply your finger on your fingerprint sensor, means your mobile is logged for now. Assume that your mobile is logged. You will apply your finger on your fingerprint sensor. What will happen? What will happen once you apply your finger on your fingerprint sensor? When your mobile is logged, what will happen? It will unlock. That's it, right? If you are the right user, it will unlock. If you are not the right user, what will happen? It will still be logged only. It will say that fingerprint not matching, something like that. It will say yes or no. So what internally it will happen is that data from fingerprint sensor goes here to I2C controllers, I2C controller, basically I2C interface of your chip, and from this I2C chip, it goes into your interconnect. From the interconnect, right, it will go to your. There'll be one additional block here called a security block. Actually, there's one block will be there in every SoC, mobile SoCs. It's called as security block, security subsystem. We call it as generally. Okay, this is security subsystem, right? This security subsystem, for the security subsystem means will take this fingerprint data inputs, and this security subsystem will authenticate this authenticate means what? Provide the checks for the fingerprint data, and decide whether the access to be given or not to be given for your mobile phone. Okay, so this security subsystem takes care of authenticating your fingerprint data. Okay, now the APB protocol will be used here actually at this interface where your APB protocol will be used. Now, why, if you ask me, sir, why APB is used here? Because the fingerprint data, it's not a 1 GB of data. Your fingerprint data, it's not a 1 GB of data. It will be some bits only. Some bits it will be there. Okay, 8 bits. Consider it's 8 bits actually. Okay, so you don't need any high speed protocols to achieve this data transfer. You need only some low speed protocols. So APB falls under the low speed protocol category. Okay, where APB protocol will be used to interface with the components present inside the chip for data communication. Now, what are the components? Interconnect is one component, and I2C is one more component. Between the two components present inside the SoC, communication to happen, we use on-chip protocols. For low-speed communications, we use APB such protocols. But whereas CPU subsystem, let's say CPU subsystem is a high performance subsystem actually. CPU, your processor is a high performance subsystem. So for those kind of subsystems to communicate, we use something called as a AXI protocol. AXI protocol. Okay, so you go to any of the processor where they're using ARM A series processor. So those A series processors interface will be of AXI type only. And you go to any of the uh, any of the processor, any of the SoCs, where the low speed interface what they will use in terms of an on chip component to component communication will be a APB protocol. So in our course we are including both APB as well as AXI will be including. Okay, where APB you will be learning in Verilog projects aspect. AXI you will be learning in after UVM. After the UVM course, we will be learning AXI protocol. Understood this point? Do you have any questions till here? Then there's something called as SPI controllers. Again, SPI also is used for interfacing your SoC with some kind of a sensor only. Okay, see sensors in your mobile phone will be interfaced with either SPI protocol or I2C protocols. Okay, SPI or I2C kind of protocols will be using what? The sensor data. Now here in this right, this fingerprint sensor is present outside, actually outside the SoC, whereas the I2C controller is present inside the SoC. Okay, between this SoC component and the outside the chip devices our communication are happening with respect to serial our communication is happening with respect to peripheral protocols. What is peripherals? Communication present whenever you have a communication present between chip boundary to the outside the chip components, we use peripheral protocols. Example is SPI, I2C, USB. These are the examples of peripheral protocols. Okay, so here I have given you an example of I2C, but similarly you will be having SPI also, where I2C controller will be present on the chip, that is inside the chip. The peripheral such as peripheral component such as fingerprint sensor will be present outside the chip. Communication between outside the chip component to the boundary of the SoC chip, we use peripheral protocols. Okay, based on the type of communication we'll use different types of peripheral protocols. Okay, is it clear? So here in this example fingerprint I have used I2C protocol here. You're having USB port, your laptop has a USB port, yes or no? So your USB port is present where? Is it present inside your chip, or the USB port is present outside the chip? Tell me, where is the USB port present?
Outside.
Yes, correct. It is present outside, right? See your SoC. See, my laptop is using Intel Core i5. That Intel Core i5 will be present somewhere in between my laptop. Yes or no? And your keyboard, display, your USB port, HDMI port, all these are present in a peripherals. Actually, they are all present externally of the chip. Okay, so so USB port as an example is present outside. You can see it actually. Do you agree? Whereas, can you see your processor SoC? Can you see it? If you want to see it, you have to break open it. You have to break open your laptop, or you have to open your laptop and you have to see it. USB is present outside the SoC. Okay, that is you can out. It means in the laptop external peripherals it is present here. So for USB to interact with your SoC, right, you will be using USB protocol. When you connect your pen drive, from pen drive to your laptop, the storage, it will use USB protocol. Is it clear? USB is not part of your training. I just included. I just told you as an example. Okay, where to use peripheral protocols. Okay. So then we'll be understanding regarding CRC generator. What is CRC generator? It is basically kind of a data integrity check what we do in a high speed protocol. Okay, such as Ethernet. Okay, Ethernet is high speed actually, 10 Gbps. Example, 10 Gbps, uh, 10 gigabits per second is what is the transfer rate will be in terms of Ethernet. Okay, 10 gigabits is a very huge data quantity when it is going per second actually. Okay, so in these type of protocols, right, how will you check the if the data is data what you transmit from component 1 is reaching a component 2, is received in a component 2 without any loss of the data? That is through using CRC generator. Okay, that logic, see, CRC generator is not a project, it's basically a logic calculation is what we will be understanding here. Logic calculation, it's not a project. I will tell you, it's kind of a logic calculation is what we will do. Okay. Okay, so this is about Verilog. Do you have any questions still here? See, I have not yet started with the demo session. I thought like let me first tell you what you'll be learning in terms of front end functional verification training. Okay, how it will be helpful. Okay, then we will go through the demo. Actually, demo means I just want to explain you what is VLSI. Okay. Is this? Do you have any questions still here? Verilog language, Verilog design and verification. Offline, online. Do you have any questions?
Yes, how much time uh, it will take to complete this Verilog digital design?
Oh, yeah. Yes. See, digital design will take 1 month. Verilog language plus the Verilog project will take 1.5 month. Okay. System Verilog will see, overall put together your course will be completed at 8 months duration. Okay. But in this 8 months duration, it's not like after 8 months you will be put into a job support. It's not like that. Basically, once you are completed with the UVM constructs, that is this concept, UVM constructs, you are good to apply for a job. Means you will be from, even from the institute also will be applying, will be pushing, moving you into the job support groups. We are having something called the job support groups. Will be moving you into the job support group. Okay, so job supports groups are separate with respect to the uh, jobs what you are focused on, like design verification and function verification are put into one job support group, DV. Both are same, design verification or function verification, both are one and the same, will be put into this WhatsApp job support group actually. So where the institute will post the uh, company profile, and with one Google Drive link where you have to share your resume there if you are interested. Okay.
Thank you.
Yeah. And parallelly, right, once you are put into job support, parallelly you will be going through the other aspects of the training such as Linux, AXI, ASIC verification concept, Ethernet MAC, RTL debug flow, SOC verification concepts, all these things parallelly you will be going through it. Now it's not like you are put into job support group blindly. Okay, we don't do that. Before we put into job support group, we do the evaluation. Okay, what is the evaluation we do? We do evaluation in each of the topics what you are taught. Example is digital design. Once digital design is completed, you will be having one evaluation test. Okay, where in evaluation test the focus is on whether you are able to answer the questions of what is asked, right? uh, you should be able to get more than 80 percentage, minimum 80 percentage and more you should be able to get it. Okay, you will be getting it if you are focusing on the sessions, you will be getting it. Okay, same thing goes to Verilog language also, Verilog projects as well. Both put together, you will be having one evaluation test called as Verilog evaluation test, where you should be able to score more than 80 percentage. Okay, now don't expect that the questions will be easy. The questions will be difficult, but the questions will be focused on your whatever you are learned in your session itself actually. Okay, so then once Verilog is done, we'll be going to system Verilog. System Verilog is again 1.5 month of training. So where we'll be learning system Verilog constructs. See, till now we learned Verilog actually, right? Verilog is purely for RTL design. Okay, whereas SV is there, right? SV is for both RTL design plus verification. For both RTL designing plus verification, we'll be using SV. Okay. So again, it's also 1.5 month of training where we'll be learning through the system Verilog constructs. Okay, and how to develop verification using system Verilog. We'll also learn. Basically, system Verilog uses a concept called as object-oriented programming language. OOPS concept it will be using. Okay. So these are the topics what we'll be covering. Once the session ends, right, you can go through this link. Okay, I will share you this link. Okay, you can go through this link.
Excuse me, sir. Like Verilog, you said it's using OOPS concepts, is it?
And not Verilog, system Verilog. System Verilog
System Verilog.
uses OOPS
OOPS
concept,
concept.
SV.
Okay.
Yes.
Okay. Verilog uses means what is that? The programming language.
Yes,
C,
yes.
C++.
Verilog uses module-based. Module-based. It is
Okay.
module-based hardware description language (HDL).
Okay.
Okay. Shruti, how about people who are taking e-learning? Shruti, I will discuss this question after the at the end. Okay. Okay, I will discuss these related questions after the end. E-learning, there are few candidates who have opted for e-learning. Okay, see, e-learning is basically a completely online training where pre-recorded videos will be given. Okay, those pre-recorded videos and the sessions, whatever we do as a offline or online training, both are one and the same. We'll be using the same presentation only to teach the concepts. Okay, but the only difference is e-learning is pre-recorded, whereas the live batch, as today what we are having, this is a live demonstration training. It's a live batch actually. Every day it will happen, right? Demonstration will not happen every day, but the training will happen every day. Okay. There won't be any difference. E-learning and the regular batches, there won't be any difference. E-learning is opted by candidates who cannot spend Monday to Friday morning 9 to evening 6, who cannot spend their time. For them, the e-learning is generally preferred. Whereas people who can spend time from Monday to Saturday morning 9 to evening 6, for them we go with regular sessions, or uh, now whatever we are having the session demo session, it's a regular type of sessions, live batch, we call it as live batch, live sessions. Okay, the job support group, all and the evaluations all are the same. Okay. I'll discuss more about this at the end, actually, not now. At the end, I will discuss. Yeah, the exams will be online plus offline, actually. Like people who come, suppose let's say there are few candidates who come to sessions, offline sessions regularly. Okay, see, when we handle with live session batch, right, the live session batch will happen both offline plus the online. Okay, so offline people who are staying nearby or who are staying near to the institute or near in Bangalore, they prefer to come to offline and take up the sessions, right? So for those people, it will be conducted offline, the examination. And for people who are not able to attend the sessions coming to the institute, for them the exams will be conducted online. Both will be a written exam only. Both will be a written exam only. It will be online for online guys and for offline guys. So even in online also, basically, there'll be one mentor, one person present, and everyone who's attending the exam through online, you should be joining that particular link, and you should be able to uh, show your screen, means webcam you should on, and show your screen, and you should answer. Okay. uh, uh, one small request. Any questions regarding e-learning and all, right, I'll discuss at the end. Actually, let me first complete with the important aspects. Okay. See, even the e-learning questions also are important, but let me first focus on the subject point of view, then I will discuss regarding the uh, e-learning, on live sessions, all those things. Okay. Once we are done with system log, right, we'll be going through UVM sessions. So UVM is, see, UVM is a industry standard, industry standard for developing test bench for verification of a verification of any design, of any design. Okay, so UVM is purely for test bench. UVM is purely for test bench aspect. Okay, where UVM is not a language, system verilog is a language, verilog is a language. UVM is called as a methodology. Okay, UVM is called as a methodology. It's not a language. So UVM is implemented. UVM is implemented using SV. Using all the concepts of SV, UVM methodology was created. Okay, so we use this UVM methodology to develop test benches for verification, and it's the industry standard methodology for test bench developing a test bench. Okay, so we will be learning what are the different methods present in UVM to develop the industry standard test benches. What are different methods present in UVM is what we'll be understanding in terms of UVM. Okay. So then we'll be going through something called as Linux training. Linux training is a 1 week training. Okay, so where we are mainly focused on Linux hands-on training, where we are mainly focused on how so Linux commands, basically mainly focused on Linux commands. So where we will be providing the access to the institute server, and we'll explain you the basic concepts of Linux commands. Okay, so why we learn this Linux, because in real time, means in industry, right, we don't use Windows for developing a project verification. We don't use Windows environment, we will use Linux environment. So before you get a job, right, you should be aware of the Linux environment. So that training will provide you here. It's hands-on training will provide you here. It's 1 week training, maximum 1 week or 10 days is a training here. Okay. This is a demonstration for front end verification. Okay, you people who are joined for DFT can also attend this, and you can choose which domain you want to opt for, whether front end design verification or a DFT. Okay. Then we, as I told you, we'll be understanding one more important chip protocol such as AXI protocol. Okay. So then we'll understand regarding ASIC verification concepts. Then we'll go through Ethernet MAC core function verification using SP and UVM. This is one of the real-time projects what we are having in VLSI Guru, where a candidate will understand the complete uh, flow of verification, starting from test plan till the verification closure, how it is done in a real-time project, is what you'll be understanding in Ethernet MAC. Now, this test plan creation and till the verification closure in a real-time project, it is not done by one person. It is done by a team of 10 people or 15 people. Okay, but now before you get into a job, right, you need to be having complete exposure to how it is done actually, how to develop a test plan, how to develop the coverage plan, how to develop the test bench from the scratch, how to develop the regression, how to develop the coverage closure, coverage analysis and coverage closure. All those things a candidate should be knowing from the step 1 till the end. Okay, that is where we are introducing you Ethernet MAC core functional verification using SP and UVM, where you'll actually have a feel of how a complete verification is done in a real industry. Okay, the hands-on feel and hands-on experience you'll be able to get it here. Okay. Next, these are all few concepts which are hardly 1 week each concept will take. RTL debug concepts, SOC verification concepts, ASIC flow, Python scripting. Python scripting is again 15 to 20 days. Soft skill. See, soft skill training, we are not keeping it at the end of our course. Soft skill training will happen once you enroll the course. From the day 1 till you get a job, you will be put into soft skill training every week once. You'll be having it every week once. Okay, it will be generally on a Friday or a Saturday. Every week once you'll be put into soft skill training. What is soft skill is you basically develop the skills to communication, your communication skills will be developed in terms of soft skill training, and your confidence in speaking will develop. That is our main focus in terms of soft skill training. Okay, so it is recommended to each and every one of the candidates who are enrolling for this session. Front end verification, not only for front end verification, the soft skill training is also present for DFT, physical design, layout. For every course whatever you opt for, the soft skill training will be part of that course. It's a request that each and every one of you should attend the soft skill training course, because in an interview, even though you know a concept, the main question comes, are you confident enough to answer that, are you confident enough, or are you having the communication skills to convey the messages, convey the question, convey the answer for the interview question, right? That is where soft skill training will help you to get that skills. Is it clear? Okay, even your English also will improve. Okay, then the course assignments. So each module, such as digital, Verilog basics, Verilog projects, system Verilog, UVM, Linux, AXI protocol, APP protocols, Ethernet MAC, every module what you learn are coming in each module will be coming up with set of assignments actually. Okay, so which is where we request every one of you to complete these assignments, because these assignments are having interview based questions. See, in VLSI Guru, lot of companies come. Sometimes they ask some new type of a question. In interview, they'll ask new type of a question. So we keep those new type of question in our assignments. We we frequently keep on updating our questions. Okay, so by that, by doing that, right, in our digital design we are having around 100 plus questions actually, sequential plus combinational. So if you are able to come do all the 100 plus questions, okay, do in the sense what, understanding and doing, not copying and doing. Okay, you can guarantee yourself that you will be able to answer any question which is coming in an interview for digital. Okay, such way it holds true for Verilog, system Verilog, UVM and other things also. But the only thing is what, you should be involved enough to attend the lab sessions to complete the assignments. Okay, it's not like we'll have only theory sessions. Okay, once the theory is done, we'll be having respective lab sessions to help you guys complete the assignments. Okay, so when you're doing an assignment, you will have a lot of questions with you. Do you agree? Suppose let's say digital, when I say you to do 10 questions as an assignment, you will have some doubts in the 10 questions, right? So those doubts is where the digital assignment support session or a digital lab session will be focused on. Okay, where you have to attend the assignment sessions, and you need to ask your doubts with the trainers and get your doubts resolved. Is it clear? So these are the contents of front end verification or front end design verification. Okay, is this clear? And coming to tools, right? See, coming to tools, we are having these three tools. Cadence means mentor graphics. See, actually it's like this actually. Siemens Costa Sim. Actually, mentor graphics, Siemens company has taken over mentor graphics, so it becomes Siemens Costa Sim. Synopsys, VCS, Cadence, Exilium. These are the three tools what VLSI Guru Institute is providing for the students for front end verification. Okay, front end design and verification. Out of these two, means all of these three tools are used in the industry for verification aspects. In my experience, I have experience with my company deals with Questasim and Synopsys VCS tool for design verification. Okay, Cadence Exilium till means my company is not using it yet. Okay, means what I'm trying to tell you is, it's not required for an engineer or for a candidate to have experience in all of these three tools. It's not needed. Okay, why? Because for front end verification, right, the conceptual knowledge is 90%, tool knowledge is 10% only. Okay, because if you have experience in, let's say, Synopsys VCS, let's say in institute, you'll be doing your things with Synopsys VCS, and you know the complete flow of Synopsys VCS for design verification. Learning Cadence Exilium will hardly take 2 days. That's it. Suppose you get into a project which uses Cadence Exilium, only 2 days the time you need to spend. That's it. Okay, and to do that also, the company itself will provide you all the required KTs, knowledge transfer documents, KT documents they call it as, where the document how to run a test in Cadence Exilium, how to see the report in Cadence Exilium, all those things will be given there. Understood? But the debugging approach, all of them remains same with respect to any tool you go. Okay, so that's where I'm telling that if you learn any one tool, I'm not saying Synopsys VCS only, I'm not saying that, any one tool if you learn, it might be Questasim, you will learn, it might be Synopsys VCS you will learn, or it might be Cadence Exilium you will learn for design verification. Any one tool you know it thoroughly, remaining the next tool understanding will be very easier. Why? Because the steps will be same, command will be different. That's it. Okay, why command is different? Because it's a different company. That's the reason command will be different. Okay, and there will be few additional features present when you go from tool to tool. Some additional features will be there. Okay, To learn an additional tool, once you're expertise in a one tool, the additional tool knowing will be all about 2 days of time in which you need to spend. Is it clear? But to learn a language, to learn a verification methodology, it takes more than 2 days actually. It will take 1 month, 2 months. Is it clear? As system Verilog, it takes 1.5 months. UVM takes 1 month. Verilog takes again 1.5 months. Understood? So your main focus should be here on in what? Understanding the language and the methodology in a design verification. That is understanding Verilog, understanding digital, understanding system Verilog, understanding UVM. And out of these three things, choose any one tool to understand in depth. In VLSI Guru, what we do is Verilog, system Verilog, we do it through using QuestaSim. UVM, AXI, Ethernet MAC, we do using VCS. Okay, you will also have an option to do it using Cadence Exilium. If you want to do it, it's an option to you. You can opt for it. Else, you can stick to only QuestaSim and VCS. The support for Cadence Exilium to run the code, all those things we'll give you in the institute. Okay, it's up to you whether you choose to learn or you don't choose to learn. Okay, is it clear? Okay, so these are the things what I would these are the contents of the design verification training or function verification training. If you have any questions here, you can please ask. Else, we'll go with the we'll continue with our demo session and understand regarding what is VLSI first thing. See here, okay, very good question. Okay, it's a very good question. Does AI take over the job of an engineer, design verification engineer? Okay, see before AI, right, before 2020, okay, what happened was every candidate would have been taken for a job. He should be trained. If he's trained, you would have landed on a job actually. Okay. Now the candidates are of two types actually. One who's having theoretical knowledge thoroughly, but practically they're nil. Practically on how to implement, where to implement the skills are zero. So candidate number two, where he knows the knowledge thoroughly and he's also very much skilled in how to apply his knowledge practically. Okay, these are the two people who could get a job before an AI before 2020. That is interview. In interview, right, they only check regarding your theoretical skills and some level of practical they'll be checking. That's it. But once AI comes, what happened, right? The candidate who is skilled in both theoretically, that is knowledge point of view, plus applying that knowledge in a practical scenario is where definitely he will land a job. But whereas the candidate who are not able to apply the skills practically, right, his job can be done by an AI actually. Getting my point? His job can be done by an AI. So suppose let's say now in a team there are 10 people present. Okay, now only 8 people are required. 2 people whose job is taken care by AI actually. And we use, it's not like AI is doing a job independently. It's not like that. It will never happen. Okay, we use AI to means as an engineer, I am using an AI tool. Okay, in my workflow. You're understanding my point, right? I am using an AI tool in my workflow to make my job more focused on the important aspect, not on the non-important aspects. Okay, example, script development. In 2020, I used to take 1 day to develop a script. Now today I am within 5 minutes I'll be able to develop one script using AI. That is how the job is with respect to AI actually. It's not like a complete job is been removed. It's not like that. Engineers and AI tools are used side by side. Is it clear? See here, front end, I told you, AI is what? AI is all about software, right? In the back end, we use more about tools only. See, back end is all about 90% of tools. 10% is where you should be using your, you should be knowing the theoretical skills. The 10% will be all about current voltages, CMOS, FinFET, all those things you should be knowing. The remaining thing you should be knowing, 90% is all about knowledge on the tool flow. Okay, where you will use some TCL scripting to develop that, to do the physical design verification, for example. Understanding my point? So even in both the cases, right, it's not like completely AI takes over. It's not like that. Number of jobs are definitely will reduce. Okay, so you should be, once you're in your training, right, you should be focused on not only on the theoretical aspect, but also how you will implement this theoretical in a practical scenario. That is what you should be mainly focused on. Practical implementation is what you should mainly focus on. If you are focusing on that, you need not to worry about AI replacing me. Like that, you should not worry about it. Okay, see, now current scenario, there are a lot of things happening, you know, right, what is happening, because of which the economy is getting a little bit disturbed actually. Okay, in these scenarios, see, no one can do anything. See, in these scenarios, no one can do anything. There are a lot of stocks, a lot of semiconductor company stocks that are getting decreased in past 3 days, right? In that case, what will happen? How will a semiconductor company come up with a new project? Not possible. Yes or no? When new project is not coming, what will happen? Jobs will not be there. Means jobs opening will not be there. Existing employees will still be present, but a new job will not arise. Do you agree? That is what is happening currently. It's not like AI is coming, AI is there, and the job is ready, job is not present. Not like that. Job is still present, but instead of 10 engineers, they take only 8 engineers. Who are those 8 engineers? Who are very much skilled, very much skilled in how to apply the knowledge practically. That is what they'll take over. Not, see, I am not an MTech guy. I example is I am not an MTech guy. No, freshers also jobs are there. See, freshers, trained freshers, not like completely out of a out of a what is it? A Bachelor of Engineering. You should be trained in the domain actually. Okay, why? Because the skills what you get out of regular college is not sufficient for you to land a job in any of the any of the VLSI based companies. Okay, because education system needs to improve still. That's what I will conclude here. Okay, that's the reason where they say that you should be able to you should be trained in a particular domain to land a job as a fresher. Okay, now again, the trained also, I told you, right, if you are having skill set, and if after you train, if you're having that skill set, and if you're having that practical implementation of way how to do, then you'll definitely land a job. Okay, is it clear? uh, MTech, right? If you have MTech, it is just an added advantage only with respect to salary. That's it. Okay, see, if you are joining in MTech, then 3 lakh or 2 lakh will be more. 2 to 3 lakh more you will get compared to a B graduate. That's it. Okay, and in MTech, right, the focus will be more about subject oriented in MTech. In MTech, when you do, suppose let's say you do MTech in VLSI, it is subject oriented actually. You learn lot of things in detail. Okay, that is what is more in MTech. Okay, anything else? Okay. I'll take session for another half an hour, and I will give you a break. Okay, till 11:35 I will take session, and I will give you a break for 10 minutes. Okay. So let us quickly See, I told you the contents what is present in terms of VLSI front end verification. So let us quickly go through go through the understanding of an electronic system to know what are the what is VLSI and where in VLSI engineer is present in an electronic system development. Okay, and what are the different flows present, ASIC flow, FPGA flow, and what are the different engineering job profiles present. Okay, first thing is understanding an electronic system. Okay, see, example for electronic system is what? Can anyone tell me an example for electronic system? Online or offline? Anyone? Can you tell me an example for electronic system? Laptop. Then what? Laptop. Only one laptop only is there? Huh? Yeah, a lot of things are there. Laptop, mobile phone, your smart watches, projector. Lot of things are there, right? All are an example of an electronic system. Now, in an electronic system, there are two things coming. One, what you see. One, which you cannot see. What you can see in an electronic system, you can see what hardware actually. If you break open your mobile phone, you can see the hardware present in your mobile phone: processor, speaker, earphone jack, antennas, yes or no, camera module, display modules, all sensor modules, power ICs, all those things are present. That is, in a mobile phone, there are two things mainly present. One, the thing what you see is called as hardware. Example is just I told you now. Mobile means what is it? Processor, camera module, display modules, IC power IC modules, power management IC. It's called as, okay, antennas. All are what? The things what you see in your mobile phone called as hardware. Then the things what you don't see is called as software actually. Example is what? Your WhatsApp. WhatsApp is a software. Yes or no? Your operating system in your mobile phone, Android, iOS, Android OS or iOS. Nothing but what? Operating system present. Right. So, what all things make up a mobile phone? One is hardware, that is your nothing but chips, processors, screen, USB ports, camera, sensors, audio. These all are what? Hardware is present in your electronic system. Example is mobile phone. And there are things which you don't see, that is called as operating system. Applications such as WhatsApp is an application, Instagram is an application, the Microsoft PowerPoint what I am using in my laptop, that is an application. The GoTo meeting what you are using online guys for joining this demonstration is an application, right? Then we have something called as firmwares, another called as drivers in your laptop. Okay, so what is an example of a firmware or a driver? USB drivers, for example, right? See, when you purchase your laptop, when you purchase a laptop, a new laptop, and you connect your pen drive into your new laptop, but your laptop fails to detect it. The reason for that will be what? The drivers in your laptop will not be updated into latest versions. Yes or no? The drivers is the one which is responsible for interacting your the USB driver is responsible for establishing a communication pen drive with your laptop actually. Okay, driver's example is what I told you, USB driver. USB driver is responsible for establishing a communication between your pen drive and your laptop actually, laptop operating system, means Windows operating system. First the communication need to be established, then only you can go and transfer the data, movie files from pen drive to laptop or laptop to pen drive. Do you agree? So to establish the connections, we use drivers. USB driver is one example. Okay. Next is OS. Your my laptop is having Windows OS. My mobile phone is having iOS. Android mobile phones are having Android operating systems. Yes or no? So they are operating systems. Next, applications such as presentation. WhatsApp, Instagram, GoToMeeting. These are all applications. So these are all the things which we don't see in our mobile phone or in any of the electronic system. Drivers, operating system, and applications which we don't see because they're all code actually, right? Do you agree? Their operating system, applications, and drivers are all about codes which we don't see. These mobile phones, right? As I told you, they are having 4 layers: hardware, firmware, operating system, and applications. Okay. Hardware example is processor, camera, sensors. Who develop this hardware? VLSI engineers are the one who's responsible for developing the hardware of an electronic system. Okay. Firmwares such as drivers, embedded system engineers are responsible for developing the firmwares. Next is what? Operating system such as Android OS, iOS, Windows, Linux are all responsible for what? Are developed by software engineers. Applications such as Google Pay, Maps, who develops it? Software engineer or application developers develop the applications. Now all these 4 layers are essential for your mobile phone operation. Do you agree? Without hardware, can your mobile phone work? Will your mobile phone work without any hardware? Suppose let's say without a processor, will your mobile phone work? It won't work. Without applications such as your WhatsApp, can, suppose let's say you're having a hardware, but you don't have any applications in that hardware. Will you be able to use your mobile phone? Even for doing call from your mobile phone, also you will use one application called as phone as an application, or calls as an application. Do you agree? Where you type the number and you click on that call button. So your hardware has something called as a communication module present, using which your application, that is your phone's application, is used to interact with it, and you do the calls and receive the calls. Without operating system, will you be able to use your mobile phone? Without an operating system, let's say without Windows operating system, without Android operating system, will you be able to use your laptop or mobile phone? Yes or no?
No.
No, right? We want some kind of a operating system to interact with our hardware actually, right? That is where we use Windows and we use this iOS, Linux operating systems, right? So how these 4 layers, see, to understand how these 4 layers, hardware, firmware, operating system, and applications, to understand how these 4 layers help in a electronic system, let us take an example of a bus with passenger. Okay, where bus is like a hardware, driver is like a firmware, conductor is like an operating system, passenger is like applications. Okay, let's say a passenger wants a passenger is in the bus, and the passenger wants the bus to stop. Is it like the passenger will go and apply the brakes of the bus? No, right? Passenger will not, see, my point is passenger will not directly interact with your bus and make the bus to stop. Yes or no? Passenger will first intimate he wants to get down at a particular stop to the conductor. Conductor will intimate, once the bus stop comes, conductor will tell to the driver saying that you stop the bus. Driver will interact with the bus, and bus means what? Driver will then apply the brake of the bus and he stops and the bus gets stopped. Do you agree? This is a flow what is present in a bus with passenger, where the passenger wants to get down at a particular stop. So that stop, the passenger will tell to the conductor will tell to the driver, and driver will apply the brake when the stop comes, and the bus gets stopped and the passenger can get down. Yes or no? This is what the actual flow is present even in a electronic system where we are having 4 layers: hardware, firmware, operating system, and applications. How this is helpful is, can take one example where take one example where pen drive to laptop you want to transfer files. Pen drive to laptop you want to transfer the files. What we'll do first, we will use applications, right? We will use application such as file manager. Do you agree? In my laptop I will use something called as a file manager. Okay, why we use file manager? To copy, we use file manager to what? Okay, we will use applications such as file manager to copy the movie file from pen drive to laptop. That command we will issue. Okay, the copy of movie file from pen drive to laptop, that command by using the GUI, graphical user interface of my laptop. That is what, taking my mouse, I'll go to my pen drive, copy that movie file, right click copy and paste into my laptop some folder. That command I will issue by using what? Application such as file manager in my laptop. Do you agree, everyone? Step number 1, what we do. Anyone disagrees with this? What happens internally? What happens internally? See above command, drivers. See, since it's a pen drive, since we are transferring files from pen drive to laptop, latest versions of USB driver need to be present. Okay, so why this USB driver need to be present? Drivers helping, these USB drivers help in establishing communication with pen drive and laptop. See, before the movie file is getting transferred, first your communication need to be established between pen drive and your laptop. To do that, the latest version of the driver need to be present in your laptop. Okay. The latest versions of the pen drive should be present. Latest version of the driver should be present in your laptop. Then only the communication will be established here. Step number 3, what happens? Operating system, OS, that is the command from application reaches the operating system, and the operating system will issue the command to drivers in laptop. The drivers will interact with hardware such as USB to perform the file transfer, to perform the movie file transfer. This is what happens internally. Okay, so when you issue the command from your application saying that you want to transfer a movie file from pen drive to laptop, So first thing is the drivers need to be present. Latest version of drivers need to be present to establish the communication between your pen drive and your laptop. The latest drivers are present. Then what happens is the OS, the operating system, will be able to issue that command to your hardware with help of drivers. Okay. Once the hardware receives this command, the hardware will what uh, perform the transfer operation. Basically, the USB hardware will perform the transfer operation of movie files from your pen drive to your laptop. Understood? Your application. What you need to understand here is how these four layers are helpful in performing one simple operation such as transferring files from pen drive to laptop. Okay, how four layers are interacting with each other. Okay, see, out of these four layers, right, your job comes in where, means as a verification engineer, as a VLSI engineer, our job comes in what, developing this USB hardware to perform the data transfer is what our job will be mainly focused on. Okay, means developing the firmwares is the job of an embedded system engineer. Example is what, developing a USB drivers. Firmware means nothing but drivers. Developing a USB driver is responsible of what, embedded system engineers. Developing applications such as file manager is responsible for what, application engineers, or nothing but software engineers. Okay, developing operating system is again a job of a software engineer itself. Is it clear? Is this clear, everyone? So when USB device is connected to laptop, USB device gets rejected. So we start doing transfer to USB devices. So USB drivers are nothing but set of assembly level instructions. See, the embedded engineers, right, they are responsible for developing the drivers using assembly level instructions. Now again, it's not like nowadays we don't use assembly level 100%, we don't use assembly level instructions directly. What we do is we develop the drivers using C code. Okay, we develop the drivers using embedded C language. We are having tools which converts the embedded C language to assembly level instructions. Okay, so the embedded system engineers, they mainly work on developing the drivers using embedded C language. So embedded system engineer develop these USB drivers, generally done using embedded C language. Does bus driver manufacture the bus? An example is, in our earlier example, does the bus driver manufactures the bus? No, right? Bus is a hardware. Will the bus driver will be responsible for manufacturing the hardware? No. The driver will be responsible for only what? Driving the bus. Yes or no? Embedded engineers will only be responsible for developing the drivers. VLSI engineers will be responsible for developing the what? Hardware. Okay. So same way, embedded system engineers is only responsible for developing of drivers, whereas VLSI engineer will be responsible for developing the USB device. Okay. This is one example of an SOC architecture, generic SOC architecture, where you can see multiple subsystems present, starting from CPU subsystem, design specific subsystem, application subsystem, GPU subsystems, memory subsystems, high speed wired peripheral subsystems, wireless subsystems such as Wi-Fi, GSM, LTE, all these models are present. You're having IO peripheral subsystems such as HDMI, display, JTAG, MIPI, all these things, right? So this is how generic SoC architecture will look like. So even your the Qualcomm Snapdragon processors or Google Tensor processors or any of the processors present, they will be also having these kind of subsystems, these similar subsystems only present in their SoCs. Okay, now it won't be exactly same. The names will vary. Okay, and there might be some additional subsystems also present. But typically, this is how an SoC architecture will look like. Okay, it has CPUs as well as the feature specific subsystems present. This is drivers which we have already learned. Okay, see it's here. As a VLSI engineer, right, you need to understand how the hardware works. See now in this SoC, there are multiple subsystems present. Okay. Now, if you are working on a, let's say, if you are working on this, once you get a job, you got to know that you are working on high-speed wired peripheral subsystem. Assume. Now, your responsible here is to understand this USB protocol, understand PCI protocol, understanding Ethernet protocol. What does 5-layer represents in each of the protocols? What does 5 indicates? 5-layer indicates. What is this interconnect? This is what the hardware knowledge which you should be able to attain once you get a job actually. Okay. To perform a verification, you need what? Verilog, digital, Verilog, some aspects of digital, Verilog, system Verilog, UVM is what you should be aware of to perform the verification. Now, verification you'll be able to perform thoroughly only once you understand the hardware. Do you agree? What you are doing, what is the verification you are doing, you need to understand that hardware first. Only then your verification will be thorough. Do you agree with me, everyone? That is where we are saying that as a VLSI engineer, you should once you get into a project, suppose let's say you are put into a high-speed wired peripheral verification project. The verification knowledge you have, that is how to develop a test bench, all those things you'll be having with respect to UVM, Verilog, system Verilog, and AXI and APB communication protocols. But what additionally you need to learn here? You need to learn the USB, PCIe, and the Ethernet. Suppose if you're working on this particular subsystem, is it clear? Now, as a fresher, 1 minute. Now, as a fresher, you cannot learn everything actually. See, as a fresher, you cannot learn everything. In this SoC, a lot of things are there. Everything you cannot learn at the same time. Do you agree? Yes or no? That is where, as a fresher, in VLSI Guru Institute, we are teaching you what is required to land a job. Additional things means the hardware aspect, what hardware knowledge you want, that you will get to know only once you land a job actually. Okay. Yeah. Please tell me, you have any questions, Karthik?
Yes, yes, sir. Actually, in the SoC architecture, there are 5 blocks. Means Ethernet fly, PCI fly, all that. They in this five will be sitting in the chip. Okay, in this 5 only will be implementing the protocols of any Ethernet or PCI, everything. How it is, sir? I just want to know, like.
Yeah, give me a minute. Let me. Yeah, charger. Yeah. So yeah, I got it. So you're asking a question where, sir, we are we USB you are having and 5 you are having, and your question is the 5 is where we implement the protocol? Is your question right?
Yes, sir.
Okay.
Yes, sir.
See, this you see here USB.
Yes, sir.
Your USB controller will be having something called as your protocol logics plus this phi interface will be there. Phi interface will be there
Oh,
like this.
okay.
Okay, this is
Okay.
both one only. This both are one component. Okay, so where this
Okay.
USB controller will be doing that protocol specific logics actually.
Okay.
Okay, and your phi will be having all about this uh, means clock recovery circuitry and uh, analog to digital converters. All those things will be present in terms of this phi layer here.
Fine.
Okay,
Okay.
why? Because see, when you can you hear me? Hello.
Yeah, yeah, I can hear.
Okay, I think my screen visible?
Yeah, yeah, it's visible, sir.
Okay, just give me a minute. I'm getting some loading screen. Give me a minute.
Yeah, yeah, sure.
Yeah. So what I'm saying is, this block, let's say USB controller block, will be having this the protocol specific logic plus the phi will be there. Phi layer will be present. Physical layer will
Oh,
be present.
yeah, yeah.
Okay. This USB, I mean this upper block, the is where it is responsible for your protocol specific logics will be present here actually. Okay, the
Okay.
USB 3 or USB 2 protocol specific logics will be present in terms of this layer. Whereas in phi,
Okay.
right, we will be having this analog to digital converter circuitry, this clock recovery circuitry, all the things we'll be having with respect to this phi layer.
Fine. Okay.
Okay,
Yeah, I got it.
yeah. Same thing with respect to others also.
Yeah, sure, sure.
Okay.
Thank you, sir.
Uh, Going further. So as a VLSI engineer, right, you need to know how and hardware works. Okay. See, that is where we say that in a VLSI career, right, the learning will always be there. Okay, that is because you'll be dealing with different types of projects. In each project, you'll be learning something new. That new will be nothing but the hardware will be the new thing. Either the hardware will be the new, or existing hardware and newer version of the hardware will be present. Example is USB 5. See, in this they are saying USB 3, USB 2. Sorry. In this they are saying USB 3, USB 2, right? There the USB 3.2, 3.2 is there now currently, right? USB 3.2. So means you need to know what additionally is differing from USB 3 to USB 3.2 or USB 2 to USB 3 is what we need to you will be learning. Okay, this is one example what I told. Similarly, you might land into IO peripheral subsystem verification also in your workflow. In that case, you should be learning regarding this encryption algorithms. You should be learning regarding different IO ports present, display IO ports, MIPI, HDMI, JTAGs, all those things. You should be learning. Okay. Uh, See, VLSI design styles, right? So VLSI design styles. First thing is, what is VLSI? VLSI indicates very large scale integrated circuits. What are we integrating? We are integrating billions of transistors. That is why it's called as very large scale integration circuits. Okay. So basically, there are two major styles in terms of VLSI. One is ASIC flow, other one is FPGA flow. ASIC flow is called as application specific integrated circuits. FPGA is called as field programmable gate array. Application specific integrated circuits are developed to operate for a specific application only. Example is mobile phone processor or your laptop processor. Okay. FPGA is something but what you there will be versions of the board present. FPGA board versions will be present. Okay, using the same version of the board, you can develop multiple things. Okay, you can reprogram the FPGA board and you can make it to operate like a mobile phone. You can again reprogram the FPGA board and you can make it to operate like a server, like that. Okay, so FPGA, yeah. So just by looking into these definitions, right, where ASIC is application specific integrated circuits, where hardware is developed for specific applications only, such as mobile phone. FPGA is field programmable gate array, where same FPGA board can be programmed to behave like different applications, right? Example like a mobile phone, same board can be programmed to behave like a laptop chip also, or server also. Just by looking into these definitions, which one looks better? FPGA looks better. Do you agree? Why? Yes. See, if you see the definition, layman definition point of view, it's always good to have one chip, one board, and you can reprogram and you can utilize to multiple purposes. Yes or no? So though it looks like FPGA approach is better, however, industry prefers ASIC design flow due to cost, basically, mainly because of the cost. FPGA, right? They're not manufactured in a bulk actually, whereas ASIC flow they're manufactured in bulk, because of which because of which per chip manufacturing will be very low in terms of ASIC flow. Okay, what do you mean by bulk manufacturing? Let's say you take a mobile phone. Suppose let's say Samsung S26 Ultra has come, where it is using the latest Qualcomm processor. Now the latest Qualcomm processor, it is not manufactured in only hundred of numbers. Do you agree? Samsung S26 mobile phone is not manufactured in only 100 numbers. Do you agree? It's manufactured in lakhs, maybe billions also. Do you agree? Because of which per chip manufacturing cost will be low. Okay, that is the reason industry prefers ASIC design flow. So if ASIC is cheaper option, then why don't we use everything in ASIC? For ASIC, initial investment is very high actually. Okay, to in an ASIC, right? Suppose let's say you want to develop, you want to establish an ASIC chip manufacturing chip product company. Okay, you in your initial investment will be very high. Okay, why it will be very high? Because you need to start everything from scratch. You don't have anything readily available. You need to start everything from scratch. You need to hire the engineers. You need to hire the architects. You need to hire the verification engineers. You need to hire the backend engineers to, right? So the initial investment will be very high in terms of ASIC. Okay. Now cost of ASIC design flow, multi-million dollars, since we need to start from the scratch. Once flow is working, per chip cost will be less. Whereas cost of FPGA design flow, initial investment is less since hardware is readily available. So whereas per chip manufacturing cost is more in terms of FPGA. Why per chip manufacturing is more? Because FPGA boards, right? They're not used everywhere actually. Okay, only in limited number of industries is where we are using. Example is defense and your aerospace aircraft manufacturing, for example. This place where you use FPGA. Okay. Is it clear? Now for ASIC manufacturing, right? ASIC design coding, we use Verilog. For FPGA design coding, we will use VHDL. Now coming to the job openings, right? Your jobs are present in both FPGA as well as in ASIC also. Okay, but in India you'll be seeing a lot of ASIC jobs openings present, whereas FPGA is used more of in US based US based companies. Okay, America is where you have a lot of design defense sector, where you are having a lot of FPGA job openings there. Okay. Then okay. So advantage of ASIC over FPGA is what? ASIC advantages are what? ASIC is cheaper, consumes less die area, means Die area means what? The manufacturing size is less in terms of ASIC. Provides flexibility to customize the design features. See, in terms of ASIC, right? We can, whatever the design features we want, we can go and implement in the ASIC flow. Okay. ASIC designs are more power efficient. ASIC can work at higher frequencies compared to FPGA, hence gives better performance. Right? These are the advantages for ASIC. Now, when you come to advantages of FPGA or ASIC, right? So, if the chip has a bug which is detected after manufacturing, FPGA style won't incur big cost. Okay, what is the meaning of this is? Suppose FPGA board has been manufactured, okay, and you found a bug in one of the features of the FPGA board. Let's say some Wi-Fi module in FPGA board is having some bug. Okay, what they do is they don't again destroy. Means they don't do the entire process from the scratch for FPGA. We don't have to implement the entire flow again in terms of FPGA. Bug can be fixed in the next versions of the FPGA board. Suppose let's say version 1 of the FPGA board is having the Wi-Fi bug. The version 2 it will be fixed. Okay, but that is not the same in terms of ASIC actually. Why it's not the same in terms of ASIC? Because ASIC is manufactured for a specific application. Let's say mobile phone. Okay, in your ASIC chip, if Wi-Fi only is not working, then the purpose of the mobile phone only will be will not have, right. Suppose let's say you purchased let's say 1,50,000 rupees mobile phone, and they are saying that Wi-Fi will not work because of some bug present. Will a customer choose to buy that specific mobile phone after paying 1,50,000 rupees? No, right? That is where ASIC, in ASIC, right, if a bug is present, we need to do the entire flow again. That is, if you found that there is a bug present in an ASIC flow, that especially in this bug site, it should have been captured in the verification stage. Now in the verification stage, we verification engineers, if we are not able to find this bug, and it is this bug goes further in the backend flow, right, and in the backend flow they are saying that Wi-Fi module is not working, then the entire process starting from the front end to back end, it should start from the scratch. Okay, now to do all those things again, double the investment, double the money, all those things the ASIC companies need to provide. So this is where advantage of FPGA over ASIC. FPGA, if any bug is present in FPGA board, version 2 will fix it. Entire flow need not to be done again. Whereas in terms of ASIC, any bug is present, entire flow need to be done again. FPGA flow is quick since we don't start from the scratch. See, FPGA boards are readily available. We don't do anything from the scratch actually. So FPGA flow is quicker compared to ASIC flow. Okay. See, in fact, FPGA is used in one stage of ASIC design flow. Okay, that is before the ASIC chips are getting fabricated, right? The ASIC packages, I mean the ASIC files are dumped into the FPGA, and again one more verification is done on the FPGA board. Okay, so in fact, FPGA is used at one stage of ASIC design flow. That design flow is called as FPGA prototyping. Okay, where FPGA prototyping is used to check the design behavior before it is manufactured. That is, before the ASIC chip gets manufactured, the entire ASIC package, the files what is present, that entire files are dumped into the FPGA board, and one more set of final verification will be done. Okay, that step is called as FPGA prototyping. Okay, what is FPGA prototyping? Implement ASIC logic on FPGA board and check the behavior of the ASIC chip. Any issues in design can be figured out before going to the ASIC production. Okay, these are the three advantages of FPGA over ASIC. Okay, do you have any questions till here? Do you have any questions till here? Okay. Let us not focus much on the cost, per chip cost, all those things. We are not interested in that. Let us go through this slide. VLSI design flow for ASIC versus FPGA. So VLSI front-end domain flow is similar to both ASIC and FPGA. In both cases, user needs to understand the design specification, implement the design using Verilog or VHDL languages. Okay, the functional verification of design behavior using SV and UVM. Okay, see, in both ASIC and FPGA, the steps remain the same. What steps remain the same? In both cases, we need to understand the design specification. Implement the design using Verilog for ASIC. Implement the design using VHDL for FPGA. The functional verification of both ASIC flow, ASIC designs as well as FPGA designs, the functional verification will be done using system Verilog and UVM itself. So where do ASIC and FPGA differ? Majorly differ in the backend flow. Okay, so the flow starting from physical design to custom layout, the way floor planning, placement, power planning, CTS, routing, and timing closures is done is the where the VLSI flow of ASIC and FPGA backend flow differs. Okay, is this clear? Take a break. Okay, take a break for 15 minutes. We'll meet up at 12 o'clock. Okay, and we'll discuss regarding the remaining aspects of the demo session. See, what we need to discuss more is ASIC design flow. We need to understand front end flow, what it is there, back end flow, what it is there, job opportunities in the front end flow, back end flow, we need to understand, and the interest what a candidate should be having in order to choose a front end or a back end. That is, back end means physical design, custom layout, DFT. DFT comes in both the front end as well as the back end. Okay, so what are the interest a candidate need to be having in order to choose this? And at the last, we'll discuss about VLSI, what VLSI Guru, what it is offering, what are the features offering in the VLSI Guru. Okay, we'll understand that also. Okay, so take a break for 15 minutes. We'll meet up at 12. Okay, thank you. Online guys, you can join the same link. Okay, the link will be still active. You can join the same link. Offline guys, you can go and you can come back at 12 o'clock. Okay.
This conference will now be recorded.
Yes, hello everyone. So let's continue with our session. So we had to discuss regarding the ASIC design flow. Okay. See, ASIC design flow, right? Let us discuss with respect to both front end as well as the back end. In terms of front end, right, means the complete ASIC flow has 15 steps, in which is divided into front end as well as the back end actually. So front end, right, we are having design requirement. It is basically design requirement is mostly a marketing part. Okay. Then we are having architects. So architect engineers will be there who will take the inputs from the design requirement, like what are the features that are required for the SOC, let's say for example. So the architect will take the inputs of the design requirements, and the architect will decide on what blocks need to be present and how the what are the blocks need to be present in the complete SOC. The architect will decide that, and he will develop one architecture diagram, okay, which will tell all the blocks present in the SOC. The RTL design engineers will be responsible for developing each of the blocks present, and the integration engineer will integrate the each blocks to come up with a complete SOC. RTL functional verification engineers is responsible for verifying the design functionality, design behavior to verify the functional verification engineers. RTL function verification engineer role. Then we are having DFT, design for testability at Verilog RTL level. Now, what DFT people do is DFT also performs the verification only, but by applying some they don't see DFT engineer, they don't use Verilog system Verilog and all. They will use some patterns, test patterns, okay, to test patterns to verify the design behavior, okay. So moreover, DFT and backend, right? Basically the physical design, we are having dedicated demo sessions for that. So please enroll for them, okay. In terms of backend, right? Backend starts with synthesis, where synthesis engineers, what they do is they will convert the RTL into gate level. Okay, RTL level means what? The Verilog code into the gates. Conversion happens in terms of synthesis, actually converts Verilog RTL to gate level. Then again, the DFT engineer will be responsible for verifying the gate level netlist. Okay. See, both the places, right? The DFT is used in both the places, front end as well as in the back end. So generally, one or two engineers will be present in the entire project to perform the DFT. Okay, the same engineer will do the DFT at front end level, that is at the Verilog RTL level, and the same engineer will perform the DFT at the Verilog gate level. Okay. Next, we are having physical design, STA, static timing analysis, custom layout, physical verification, graphic design system extraction, fabrication, post silicon validation, and packaging. Okay. See more about the physical design, custom layout, right? That is backend demo session. Attend the backend demo session. Okay. I am not the right person to speak about this entire flow. Okay. So front end, again, we are having what in the LinkedIn, right, for freshers, right? You can see these job roles present, actually. RTL design engineers, RTL integration engineers, RTL verification engineers, right? And DFT engineers. Okay, architects, they are something who is having 10 plus or 15 plus years of experience. They are called, they are the ones who go into architect roles. Okay, and design requirement is all about marketing. Actually, it's nothing but a sales team, marketing and sales team. Okay. So that is, if I show you, right, the the front end domain flow, job requirement. I'll come to the before PPT, but the job roles, if you see, these are the job roles present in terms of front end domain. Okay. I told you earlier, like marketing team, chip architects, RTL design engineer, RTL integration engineer, functional verification engineer, and DFT engineers. Okay. Now coming to the project requirement, right? Coming in a project, right? Coming to the project requirement. Okay. So if the project is on a mobile SOC project, right? So total team who will be working on a mobile SOC will be close to somewhere around 50 people. So out of 50 people, the front end domain, that is architects, design team, function verification team, will be close to about 25 to 30 people, and the back end domain also will be close to about 20 to 25 people. Right. So the major roles will be more number of candidates, engineers will be required mainly on the functional verification side and on the physical design side, actually. Okay. When I say more number, I am speaking about 15 to 20 people compared to others. 15 to 20 people are used in functional verification as well as in the physical design. Now, design team, right? See, design team consists of both RTL design engineers plus RTL integration engineers. So basically, there'll be 4 to 6 people present, and there'll be one or two architects will be present in terms of architect engineers. 1 or 2 will be present. Okay, again DFT also, as I told you, two people, okay, 2 to 5 they are saying, but basically 2 people will be there in terms of DFT. Physical design 10 to 15 people, STA 3 to 5 people, and layout 3 to 5 people. Okay, this is the back end actually. Okay, so this verification course, front end design and verification training for freshers, it is targeted for design as well as for function verification also. Okay, as a freshers, if you want to get a job. Now, what are the skill sets required? VLSI front end domain flow. VLSI front end domain flow is similar to software flow actually. I'll tell you in some time. I'll tell you what are the skill sets required also. But the VLSI front end flow, what we have, it is very much similar to the front end of the software also. Okay, where in as a software engineer, right, the skill sets required for a front end development is C, C++, Java. You should be knowing, and they should be very good at reading the software specifications. So okay, understand the software specification, develop algorithms, and implement the same using C, C++, Java, or similar languages. Basically, what will the software front end engineers will do? They will understand the software specification and develop the algorithm based on C, C++, Java. Okay, so for becoming a software engineer, they should be having a good programming skills. Okay, now coming to VLSI front end engineers, right? Verilog SV UVM is what we need to be familiar with to become a front end engineer. So should be good with programming or have inclination towards programming. Okay, now when I'm saying good, right, interest you should be having to do programming, that's it. I'm not saying that you should know a programming language to learn a front end domain. It's not like that. If you want to learn front end domain, you should be having interest towards programming, that's it. Why am I saying that? Because even if you don't know C, C++, Java also, that's fine. In terms of front end training, we will teach Verilog, system Verilog, and UVM from the basic, from the scratch level. We will be teaching it. Okay, so even if you don't know C, C++, Java, that's all right. But if you are having interest towards programming, right, you can learn the Verilog, system Verilog, UVM from the scratch. You can learn it. Okay. Along with system Verilog, and UVM, right? An engineer should also be capable enough to read hardware design specification and understand the design functionality. To get you familiar with reading the hardware specification document and understanding the hardware specification document is where we are doing Ethernet MAC project. I told you in the initial, right, we are doing Ethernet MAC project. That is where you will learn how to read a document and understand the document. Okay, and implement requirements using various protocols: USB, PCI, DDR, AMBA, SPI protocols. Now, what do I mean by this? Based on where you get a job, which project you will get a job, you should be able to learn various protocols and you should be able to implement them. That is what I'm saying here. As a freshers training, we are including AXI and ABB protocols and SPI protocols. We are including 3 protocols. We are including as part of freshers. Okay, but suppose let's say well, you got a job as a fresher and you are put into USB verification project. Let's say you should be taking that initiative to learn USB protocols, because as a fresher USB is not taught. Okay, USB and it's all advanced protocols actually. Okay, so you should be able to take initiative and learn the USB verification hardware specification. Only then you can perform verification on a hardware. Okay, so software doesn't require any backend flow in software, right? Once you develop an algorithm, you don't convert that algorithm into some kind of an hardware or something like that. No, it won't happen. So software has only front end flow. Okay, software backend flow is not present. What is backend flow? Backend flow is a process of converting the Verilog RTL code into the chip. That is what is the backend flow what we are having. This backend flow is not present in software. It's only part of hardware, that is VLSI. So in software, the code is installed and used. No need to manufacture a chip out of a software algorithm. So in VLSI, the front end verification plays a very important role. If there is a if there is a bug in the chip, which is detected once it is production, bug cannot be fixed actually. Okay, so that is, if you notice the front end flow, ASIC flow, right? The functional verification comes here actually, and this acts like a very major part in the chip manufacturing. Okay, why? Because once the design gets implemented, and once you do the verification on the design, during verification you missed out some feature to verify actually, and that feature has a bug and you didn't verify that bug. Okay, so what will happen? It will go into backend flow. The same bug will be present in backend flow, physical verification. Everywhere the same bug will be present. Okay, if you don't capture that bug here, the same bug capturing it in the backend flow is very rare scenario. Okay, and what happens? The same bug gets implemented in the hardware also. What happens? Your mobile phone will be defected, right? Lost to the company. Okay, or in any of these stages, if the flow gets caught, it has to again start with the design verification stage itself. So the time and the money spent in the synthesis engineer, DFT, physical design, all these things, time and money will be wasted. Do you agree? Right? Mainly on the money gets wasted here. I mean, the company again needs to spend the same amount of money for the engineers. Yes or no? Right? So in VLSI, right, the functional verification plays a very important role. If there is a bug in the chip which is detected once it is produced, bug cannot be fixed. The entire flow needs to be done again. VLSI chip doesn't have any concept of patchwork. In terms of software, right? If suppose let's say you have updated your mobile phone into a latest operating system, and your latest operating system had some bug, what will the OS means? What will the company do? Company will provide a patch which will deprecate that particular feature current for the current month, and then next month they will release one more software update saying that there is one more software patch saying that the bug is fixed. Such kind of patchwork cannot be done on a hardware actually. Okay, that is, once the hardware is manufactured, bug will be present. You cannot go and do some kind of a patch on that hardware to fix that bug. Not possible. The only way to fix a bug is what? Again, redoing the entire step from the front end to the back end. That is from the design verification to the back end flow. Okay, job rules. I just discussed this one. DFT. See, DFT again. We won't be discussing on DFT because DFT is a different course altogether. So anyone is interested in DFT, right? You can enroll for the DFT demo sessions. Okay. As I told you, what is the interest here? Interest to learn front end design verification. What is the interest? Interest should be what?
Program.
Yes, doing programming. Okay, programming will be in various things. It will be Verilog, System Verilog, UVM, and Python. Python scripting. Python scripting, we'll call it as. Okay. The same thing if I give you one more example, means interest to learn backend domain, I'll say backend flow. It can be DFT. I'll include DFT also, because DFT also you don't need to know anything of programming actually. For DFT, only some theoretical and tool knowledge is sufficient. So DFT, PD, etc. That means custom layout you have, right? Custom layout, etc. Interest should be in theory actually, in theoretical. Interest in learning theory. Okay, CMOS, FinFET, design rules, all those things, theoretical, you need to be learning here. Okay, voltage, current, all those things, you need to be learning here. Okay. So if if you don't have any interest, my simple point is, if you're not having interest to do programming, don't join front end design and verification. Join backend. Okay. If you're having interest to do programming, learn front end actually. Okay. See, in terms of front end, right? Programming will be 90% of the time you will do programming. Okay. 10% you will do what? Scripting. Not scripting, tool. 10% tool you will be using. Tool usage. Whereas in terms of backend, right, what happens is programming will be only 10%. The remaining 90% will be all about tool usage. Tool flow, we call it as the tool flow. For physical design, tool flow, we call it as. The tool flow you should be knowing with respect to synopsis or with respect to cadence, mainly. Mainly with respect to cadence, the tool flow you should be knowing. Okay. Coming to session timings, right? Session timings. Front end, I'll tell you with respect to front end, because I handle front end, so I am aware of front end session timings. Digital, right? Digital, you'll be having theory sessions plus assignment sessions, we call it as assignment sessions. Okay, where theory will be morning 9:30 to 12:30 p.m. or 1 o'clock it will be going. Okay, and assignment sessions will be done in the afternoon time, 1:30 to, let's say, 3 p.m. You'll be having assignment sessions. Okay, what is assignment sessions? Digital, right? You are having 100 plus questions, combination plus sequential. So those questions are as an assignment in the theory. In the theory, we'll learn the theoretical topic. That respective theory topic assignment we'll be discussing in the assignment sessions of digital. There is no lab in digital. There is no lab. Like in engineering, you would have come across some digital labs, right, where you would have done some IC, all those things you would have used. That's kind of things are not there in terms of digital sessions in VLSI Guru, because it's not needed actually. Okay. You will be, when I come to system Verilog, UVM, and other things, other modules, AXI, Ethernet Mac, Python, Linux modules. Theory plus lab will be there. Okay, where theory, again the timing will be same itself. Okay, the lab session, each module has some 10 to 15 set of assignment files. Okay, so where each assignments will be having 10 to 20 questions. Okay, so the lab session will be focused on helping the students to understand the assignment and do the assignment and provide the support for the assignment. In the lab sessions, trainers will not do the assignment manually. Trainer will not share the screen, and trainer will not read the question and do the assignment each one by one. That's not the role of an assignment session. Assignment session is what student needs to do the assignment and ask the required support from the trainers. That is what is meant by assignment session. Is it clear? Okay. I hope I'm audible online, guys.
Yes.
Okay. So the lab session, right? In lab sessions, it'll be from 1:30 p.m. Oh, not 1:30. I think 2 p.m. Okay, 2 p.m. to 4 p.m. You'll be having lab sessions. Okay. Sometimes it might be for 3 hours also, based on the content of the theory. Sometimes session can go till 5 p.m. also. That's where we are saying that people who are able to spend on a weekday morning 9 to evening 6 are the one eligible for taking live batch training. Okay, live batch means what? As now what we are doing demo session, this is a live batch demo session. Okay, whereas people who cannot spend the time because you might be occupied in some college works or some you're having some jobs, right? So in that case, you have to opt. You can opt for uh, you can opt for e-learning. E-learning. Okay. Yeah, one Deepika. In design verification front end, the coding will be more. Then it will be a tough to get job. Why do you think it will be tough to get job? I don't understand. Why do you think like that? Could you why are you thinking like that? Could you please tell me? See here. Uh, okay. See here. As personally, openly I'll tell you one personal thing what I did. Recently, I've changed my career. I've changed my company. Okay. If you have, what I found out was, if you have a good resume means what? Your skills actually. Your skills is what you will be putting in your resume actually, right? A good skill set, a good skill plus uh, good presentation in your resume actually, in your resume. Okay, this will hold 90 percentage. I will tell you. The remaining 10%, right, is all about luck also. Sometimes they say, right, even if you know everything, there should be some luck actually. I'll tell you 99% your hard work, what you put in your resume and in your training or in your career is what comes. And the 1% luck is there, right? That 1% luck for luck plays a very important factor in getting into a job actually. Any job it can be there, not only front end, back end, any job. Okay. So what we can do, we can only focus on this 99%, right? Do you agree? We can only focus on this 99 percentage of hard work in getting good skills and to be more means to develop the skills so that it should be more presentable in the resume, right? Only those things is what we can control actually. Okay, the remaining 1% we cannot control. If that 1% luck you're not having, right, you cannot get a job even if you know everything. That is what it is actually. Do you agree? Good behavior, good skill set, good mindset, good presentation is what we can control in getting a job. Now, if you're having a bad attitude, right, you cannot, even in an interview, if you show some bad attitude, you cannot go and get a job, even if you're having good skill set. Your attitude also matters. Okay. So that's what I'm saying. Good presentation is where all the things involve: attitude, behavior, right? How you present the things in your resume, all those things is what we can control. Okay, it's not like coding. See, it's not like if coding means it's tough to get job. Not like that. If you're having good skills in coding, you can also answer any difficult coding questions. Yes or no? Right? See, today I'll ask you one question, coding question in interview. What they'll ask. Okay, write a logic to perform reverse uh, to uh, to arrange given numbers in descending order. Right? This is what question. This type of question is what they'll ask mainly for a fresher level interview. Okay. Now, basically, what we need, what is this? What is this? What is the understanding of this question actually? I mean, what are they asking you in this question? We need to arrange the numbers what they have given. Let's say the numbers is 10, 5, 50, 32, 5, sorry, what is that? 8, 15, like this numbers they have given. This number you need to arrange them in descending order. What is descending order? What is descending order? Big to small. Bigger number first, smaller number last actually. Okay. Now today this question might be, I don't know how many of you are thinking of this, but today this question might be difficult. Okay. But the same thing after doing your SV course, right? Verilog SV course, you'll find it 50%, 60 to 70% easier, 30% you'll find it difficult. Now, why the 30% you'll find it difficult? Because you are seeing this type of question for the first time actually. That will be the reason 30% you'll find it difficult. Where difficult, how to write the logic is where you'll find it difficult. The logic you'll keep in mind, but how to implement it is what you'll keep it difficult. That is where what you should be doing more is you should be learning things not only with respect to theoretical, also implementing it practically. So in our SV, in system verilog and verilog UVM sessions, right, we learn theory, right? The same theory what you learn, you will be doing it in practical actually, which will make you to answer these type of questions, which will make you to answer these type of questions easier, is what I'm telling. Understood my point? Okay, these similar questions when you do more frequently by using Verilog and SV, means you'll find such similar questions more easier to do compared to you'll find these questions more easier to do. Okay. Okay. So what I'm saying is, in programming, right, you should be having good skills. What is this good skills? Theoretical knowledge plus practical implementation of that theoretical knowledge is what good skills is all about. And whatever you learn, right, you should be able to present it. That is where your soft skills comes in actually. Okay, you should be able to present it actually, because if you're having good knowledge but you're not able to present it right, you won't be able to go anywhere. Okay. Fine. So do you have any questions apart from this? Few of you had some questions. If you want to ask me, you can ask it.
Hello, am I audible?
Yeah, who's this?
Kavita. So
Yeah, hi
actually, I
Kavita.
joined a little late. So just would like to confirm, as I have enrolled for FPGA design and verification course. So does this going to, I mean, cover the FPGA related topic also, or are we going to have any different session or separate session?
Uh, See, regarding that, right? You can
Uh,
see I have covered front end aspect. Front end aspect involves
okay.
FPGA also. But
Okay.
if there is any dedicated demo sessions, I need to check with the institute also if they have arranged for any dedicated demo session for FPGA. But this
Yes.
front end demo also, I have also spoken regarding FPGA also, basically.
Okay. Okay.
Okay.
Okay. And
Yeah.
another thing is like we are going to have the lab session from 2 to 5 p.m. So do we need to install any tools or everything will be covered in the lab session itself? I mean, any prerequisites are there?
Okay. See, it might be for FPGA or it might be for Verilog ASIC flow, that is Verilog SV UVM. You don't need to worry about the tool installation because when each
Mm.
module starts, let's say Verilog is going to start. See, next is
Mm.
after this demo session, you'll be starting with digital actually. But after
Okay.
digital, Verilog or FPGA will start. Okay. So
Okay.
that time, the trainer will help you to get the tools installed actually in your laptops. Okay. You don't need to worry about it now.
Okay.
Institute
Okay.
will help you to do that. Okay.
Okay.
Yeah.
Hello.
Yeah.
Yeah, I am Ashwini. Actually, can you tell more about the e-learning course, how it works?
Okay. Okay. E-learning. E-learning. E-learning is see. First thing is you'll be having access to one PPT actually. The same PPT, even the live batch trainers, students also will be having access to same PPT. The only thing what differs in e-learning is pre-recorded videos. Okay, these pre-recording videos will be 1 month old actually because every 2 to 3 months we will be updating our videos. Okay, so it is latest video only what we have. So these pre-recorded videos access will be given module based. Module based. What do I mean about module based? First, digital access will be given. Okay, first digital access will be given. Okay, in digital access, what means you will be learning regarding uh, combinational circuit, sequential circuit. The only advantage what you get is you can go through these videos in your own time actually. Okay, like every day 1 hour you can go through in your own time or 2 hours in your own time you can go through it. Once you complete your digital training, you will be getting one. You will get a evaluation. Evaluation test will be there. Okay, this evaluation test you have to get more than 80 percentage. Okay, once you complete the digital access, if you intimate to the management, right, saying that you have done with your digital access and evaluation is done, you can go to the next module such as Verilog. Okay, such way it happens for each module. Each module access given, go through it in your own time and complete the evaluation test. Intimate to the institute saying that you have done with a particular module. The new module access will be given to you. Okay, this is how e-learning will go. Along with this, the support means students doubts and the doubts and any support needed with respect to technical, that is subject, with respect to subject matter, can be requested by student in one-to-one dedicated one-to-one WhatsApp group. Okay, so based on your doubts, right, the trainer will arrange a session with you actually. Okay. These doubt sessions you cannot expect every day. Okay, maybe weekly twice or weekly thrice you can arrange the session. Okay, is this clear? And the same way, the job support also the same way it is for e-learning or for live batch, right? Job support group remains the same only. That is once UVM is completed, uh, based on your evaluation results, you will be put into job support group. See, why it is based on evaluation? Because if each time evaluation, if you are getting some 10 marks out of 100, it's below the expected. If you're getting right 10, 20 like that, you cannot expect from yourself also that you will be getting a job in a company also. Okay, because that skills you have to develop first. That skills evaluation is what we are doing in the evaluation test. Okay, the minimum criteria we are having 80 percentage. So once you are able to meet that criteria, we'll be putting into the job support groups. Is it clear? Now that initiation you have to do it from your end. What initiation? Getting the skill set. We are providing it. You should be able to receive it from your side. Take it seriously for next 8 months of duration, and uh, attend the sessions, attend the lab sessions, attend the theory sessions regularly. Doubts if you're having, clear it then and then. Be open in the sessions. That is the main thing actually. Your confidence level will you can from day one itself you can improve your confidence level when you interact with the trainer every day from the day one. Okay, which I see only in my sessions. I'll tell you, I see only 2 or 3 people only doing it out of a batch of 40 people. Getting my point? Only 2 to 3 people, they will speak and they will ask the doubts regularly. Okay, I don't know what other people are doing. It's either that they might be understanding everything, or it can be they're not understanding anything. Getting my point? Now we cannot go for each and every student did you understand this topic, did you understand this topic, did you understand this topic? Each and every day we cannot go and ask for a student. Actually, it is your responsibility to ask and clear your doubts in a sessions. Okay, do you agree? Like, see, if I'm teaching 2 topics, if in a 40 people, if let's say 5 people are able to answer those, ask the questions and clear your doubts and answer the questions to what I'm asking, and if the remaining 30 35 people are not able to answer, what is the meaning actually? Tell me. There will be 2 things. Basically, there will be three things actually. One thing is what? You're understanding everything. Okay. Second thing is you're understanding nothing. Third will be what? You're understanding, but you don't want to answer. You don't want to reply. Now, if that is the case, we cannot do anything. Okay. So you should be able to take that initiation and ask a doubt if you are not able to answer. In my sessions, I will really encourage the people to speak, actually be interactive and be speaking, so that the sessions will be more lively rather than a dead session. Getting my point? Okay. Any other thing, any other questions you have, Ashwini? I hope this
Yeah,
addressed most of. Yeah.
thank you.
So there is functional verification for working professionals. How it is different from this one? Is it the
Yeah, Samir.
same?
Yeah. See, functional verification for working professionals, right? Basically, there'll be some additional projects being present. That's it. How it will vary? Additional projects will be there. Additional protocols you'll be learning. Okay. So for freshers, we are only keeping AXI and APB. For experience, right? You will be learning some additional projects, AHB protocol, UVM in more detail. You will be learning. You will be learning Ethernet MAC plus USB protocols, like that. It is more.
Okay.
There will be few similar things, but additional things in with respect to projects and protocols will be added.
Okay. Okay.
Hello, Himanshu here. Is this demo session is only for front end, or do we get a separate session for back end also?
A separate session will be there for backend. Most probably it will happen tomorrow, Sunday. You can timing, right? You please reach out to the management. Okay. DFT and PD, that is a backend demo session, will be happening tomorrow, most probably. You please check with the management for timings. Today's session was all about front end actually.
Thank you.
Yeah. Shruti, see, for experienced people, right, how different protocols and projects will be covered if it is recorded. See, even there are pre-recorded videos for the additional protocols and additional projects what you have. We are having dedicated videos actually. Okay, we are having dedicated videos for freshers and for experienced also. Okay, it's in a module based. So those experienced, means if you're enrolling for an experienced engineer, as an experienced engineer, if you're enrolling for, those additional videos will be given you access. You don't need to worry about that. And the support sessions will all will be the same. Okay, support sessions will all be the same. Okay, see, based on what interest I prefer to work. See, I'll tell you openly. I During my time, right, there was no exposure to VLSI actually. No one knew what is VLSI that time. I have done only BTech. Okay, so in my home, expectations was all about once fourth year is done, I have to get a job. Means during final year, placements interview, placement should be, campus placement should happen. That is what the expectations was there. Okay, but from the day one, that is starting from my second PU or first 10th standard itself, I was always part of some Arduino based projects actually. Okay, so every year I always had a focus on hardware itself actually. 10th, 11th, 12th, I always used to be part of some electronics team. Okay, so in my final year, right, when question came, I need to get a job. I also tried for a job in software domain, but I never found that interest to work in a software aspect actually. That is where I told my family people, saying that I don't want to get into a software domain. I want to get into a hardware domain actually. At that time, everyone were against it because no one knew what was means family guys, they didn't know what was the importance of semiconductor actually. Okay, that time many people have told that don't go there, you will not have any career, all those things. They told all those things. They told that join TCS. I had an offer letter from TCS also. They told join to TCS, but I never had the interest. I never had the interest to join software as a software engineer. Okay, that is where I chose my interest as my uh, career, and I went to semiconductor, and now all is good. And now the same people, they are coming and they're saying that it's good that you have joined semiconductor. Getting my point? How the words changes, right? The only thing is what you are interested in. That's what matters. If you're interested in a subject, if you proceed with that career, you'll always find it happy to pursue it. If you are not having that interest, right, you will always feel that something is lagging. Okay, you are doing job just to survive. That should not be the case. Okay. uh, Deepika, we have to learn tools own, or otherwise you will explain the tools. See, we will explain the tools. See, I told you, right? I think VLSI Guru offers three types of tools: Costa Sim, VCS, Cadence, Exilium. So in each of our modules, when we learn Verilog and System Verilog, in the institute only we will teach with respect to Costa Sim tool. When you go to UVM, in the institute itself, we will teach with respect to VCS tool. Two tools we will teach in the institute itself actually. Okay. Cadence Exilium, right? What happens is, if you are interested to learn Cadence Exilium, we will provide you the access for it, and we will help you also, but only if the candidate is interested to learn Cadence Exilium. Okay. But my personal opinion is, out of these three tools, choose one tool, become an expert in the training, then remain the next tool, right? You can always learn it when you get into a job actually. In a job, no one will ask in front end job, right? No one will ask saying that you know Synopsys VCS, then only you are hired. You know Cadence Exilium, then only you are hired. Like that, no one will ask. Okay, no one will ask. Any one of the tool, if you are having knowledge, sufficient. Is it clear,
Yes, sir.
Deepika? Fine. I'll be just give me a minute. Okay. Okay. So if you have any questions, you can ask. Else, we'll be ending this session. Okay. I'll also give you some contact number if you have anything job related queries. If you are having VLSI group placement, right? Placement related queries. If you have, I'll give you one contact number. You can contact that. But if you are having any technical doubts, right, which you want me to address, I will address it. No questions online, guys?
Hello? Yeah. So I have, can I ask related to placement related?
See, placement, right? You can ask to our VLSI Guru manager because he takes care of the placements. Okay, I'll send you his number. Everyone can please note it down.
And sir, this demo session is recorded session will be shared, sir.
Yeah, it will be shared. Yeah,
Okay. Thank you.
yeah, thank you. 99861 94191 Yeah.
So the next class will be at 2 p.m.
No, no, no. Today it won't be there. Today was only demo sessions. Okay. Today you don't have any session in the afternoon time. Uh, the timing what I mentioned, right? It was for when digital starts, when digital training starts actually. So most probably it will start from next week, either from Monday or from Wednesday. It will start. Okay. The timing and all it will be informed to you in the group. Once the demo session is completed by today evening, the when the digital training starts, those things will be told to you in the WhatsApp group. Okay.
There is no lab session today.
Uh, Today there is no lab session. Today we are only doing demo session, right? There is no lab sessions.
Okay, sir. Thank you.
Did everyone note down this number? Okay. His name is Vaibhav. He's from VLSI Guru Placement Management Team. He's a manager of VLSI Guru who takes care of placements. So you guys can contact him if you are having any queries. Okay. Okay. Sure. Thank you. I hope you had a good time in this front end demo session, and I hope that we will meet in one of the upcoming modules in front end design and verification. Okay. Thank you.
Thank you.